how to determine brace wall band spacing as it applies to Part 9 lateral bracing design. So I just wanted to go over a few very simple examples here to illustrate this concept. What I have in front of me here is a simple floor plan. Let's just consider it a single story at this point of a house or other similar building. So the first thing the designer needs to do when they're determining band spacing is, well, first they need to locate their brace wall bands, which are a conceptual item, on their floor plan. And so the first thing they're going to do is surround the perimeter. So I'm going to do that here. These are the three walls that are on the perimeter on the horizontal axis. Then I'm going to do the two end walls. And then in the middle here, for that front jog, the designer has an option. They can either just do a short wall and join up those two bands, or they can run a brace wall band all the way through. Now, once we have a brace wall band plan that's been installed according to the rules, and let's just hypothetically say that's achieved here. You can see all the ends of the bands are lapped with another band. There are no open corners. The perimeter of the building is surrounded in bands. And let's just say, for example, all those jogs at the back right and at the front center there, they're all jogs that are less than 4 feet, so they're captured by the maximum width of a brace wall band. Now, to establish an understanding of the brace wall band spacing, the first thing we need to do is measure the distance between the furthest end bands in each orthogonal direction. So I'm going to start with the bands that are running up the vertical axes, so the bands that are running sort of horizontal along the page. And I'm going to start by measuring out the center lines of the furthest end bands. So that's the center lines there, and let's say hypothetically I measure that out at 10 meters. Once we have this measurement, I can then go ahead and label or identify the brace wall bands that I have running up that axis. So I'm going to call this one A, B, and C. So now I know that I have 10 meters between the two ends, and I have 3 brace wall bands in that orthogonal direction. I apply the same concept and philosophy, I guess, to the red brace wall bands that are running vertically. So again, I measure out between the two furthest, the center lines of the two furthest end bands at 15 meters. I can ID the bands, and I call these ones 1, 2, and 3. And so again, now I have a distance between the furthest end bands, and I know how many bands that I have. So once I have that information for both orthogonal directions, it's very simply a matter of just doing the math to calculate the spacing of these bands. The BC allows us to average band spacing for our calculations of determining an amount of bracing length. So here, for the bands running parallel to the horizontal axes, so that's the bands labeled A, B, and C. We have the distance between the furthest band center lines at 10 meters. The number of bands is 3, so the band spacing is 2. Therefore, the average band spacing is 5 meters. Similarly, for the bands parallel to the vertical axes, so these are the ones labeled 1, 2, and 3, we've got 15 meters between the furthest end band center lines. The number of bands is 3, the band spacing is 2, and so the average band spacing is 7.5 meters. Now, it's important to remember that there is a rule that relates to band spacing, and hence to the average band spacing as well, and that is that bands cannot exceed 10.6 meters between their center lines. So you can see with this design that we have in front of you here, that's not going to be an issue. So moving on to the second slide, let's just create a little bit of a different example. And I alluded to it in the first slide, but this is definitely something that comes up a lot for people. It's a point of curiosity. So here we have exactly the same floor plan, but I've just changed the brace wall band design slightly. And that is that center band, the red one labeled 2, now instead of continuing all the way through to the rear wall, it actually just stops at the front wall. And ultimately, the results are the same. Okay, so for the bands parallel to the horizontal axes, we still have 3 of them, still 10 meters between the furthest, so our average band spacing is 5 meters. For the bands parallel to the vertical axes, again, we still have 3 bands. Even though that center band is not continuing all the way through, we still have 3 bands in this orthogonal direction. The furthest distance between the center lines is 15 meters. The number of bands is 3. the band spacing is 2, therefore the average band spacing is 7.5 meters. So as I said on the previous slide, there is a rule that says that we can't exceed 10.6 meters between band spacing, and obviously we're not doing that on our plan here, but it is a little bit of an adjustment to think of, say for example, on the plan you're looking at now, between band 1 and band 3, at the end, or I guess at the back wall there, the spacing is beyond 10.6 meters between those two bands. But to my understanding, this design as it's represented is still a compliant brace wall band plan. And part of the rationale behind this is that the way the mathematics works of the calculation method is that when we attribute an amount of resistance to lateral loads to each of our brace wall bands, it doesn't actually matter how long our brace wall band is. The only factor that I can understand that is actually affecting the amount of bracing that relates to the length of a band is essentially the length of a building, right? But we're not really defining that here. We're just defining the location and the number of brace wall bands in our plan. So essentially, if we were to compare the example that I had before, example 1, where that centerline band runs all the way through the building, and if we will compare it to example 2 here, where that brace wall band stops at the front wall, the same amount of resistance to lateral load would be required to be installed and constructed in both of those bands. It doesn't matter which option we actually choose in terms of how we design our brace wall band plan. The same amount of resistance to lateral load would be required in each of those bands. So just going on to a third example here, introducing a little bit more complexity to the brace wall band plan. Here I have installed obviously another brace wall band running parallel to the horizontal axes, and I've identified there on the left hand side as C. So now we have A, B, C and D as our brace wall bands running up the vertical axes. So this is going to change our calculation slightly. Now we still have the same distance between furthest band center lines as 10 meters, but now the number of bands is 4, so the band spacing is 3, and the average band spacing is reduced to 3.33 meters. For the bands parallel to the vertical axes, the distance between the furthest band center lines is 15 meters, the number of bands is 3, band spacing is 2, so the average band spacing is 7.5 meters. And again, just a reminder of that rule, that our band spacing and hence our average band spacing cannot exceed 10.6 meters. Final example, a little bit more complexity here. In this case, so the bands parallel to the horizontal axes, again we have 4 of them labeled A, B, C and D, and then our bands parallel to the vertical axes we now have 4, and we're labeling them 1, 2, 3 and 4. So the mathematics plays out again. For the bands parallel to the horizontal axes, we have center lines, further center line dimension of 10 meters, number of bands is 4, average band spacing is 3, so the average band spacing is 3.3 meters. And then the bands parallel to the vertical axes, the distance between the furthest band center lines is 15 meters, the number of bands is now 4, the band spacing is 3, and so our average band spacing is 5 meters. Hopefully that clears it up a little bit for people. If you have any questions, please feel free to reach out. Thanks.